Hello, my Algebra 2 friends. This is 1.6. We're going to have part 1 and part 2 videos, and I'm going to try to separate them. So hopefully I remember to separate them. 1.6 part 1, we're going to be solving absolute value equations. And then for 1.6 part 2, we're going to be solving absolute value inequalities. So we're going to kind of put all of our thoughts together at the end of this unit here. And the good news is there's a lot of overlap to concepts. So that is good news in math. So we have the idea of absolute value, and the way we notate that in math is we use these bars. They just look like two vertical bars. Absolute value measures the distance from 0. So that's why your answer after computing an absolute value always comes out to a positive value. So if you're like, how far are you away from school? Like, I'm 6 miles away from school. You don't say I'm negative 6 miles away from school. It's just the distance from 0 and the number line. So when this involves algebra, it gets a little more complicated. Of course, because it's algebra. So here's what we're supposed to think about. If we have this question, the absolute value of 2x minus 5 equals 9. That means, I'm going to do something kind of weird. Don't do this on your notes, just watch me. Whatever gobbledygook is inside these absolute value bars, it could be 9 or it could be negative 9, right? Because absolute value of that would be 9. So I'm going to hurry up and erase my mess. That's what they have set up for you over here. They're going to set up two problems. So the stuff that was inside the absolute value bars, 2x minus 5, it could be 9 or it could be negative 9. One thing I want to point out, they did not change the algebra that was inside the bars. That's very important. Never change the algebra that's inside the bars. And now you just solve, like use your gut instinct. What do you think you're going to do? You're going to solve. So I'm going to add 5 to both sides of the equation here. And then we end up with 2x equals 14. And then we're going to divide both sides by 2. And I wish I had more space to write. I apologize. So x equals 7. So that's one solution. And we're going to do something very similar over here. We're still going to add 5. But because we started with a different solution, instead of 9, it was now negative 9, you're going to get a different solution. So 2x equals, that's a negative 4 when you add those up. And then divide both sides by 2. And you get x equals negative 2. So then this would be a good time to ask yourself, well, which one is the right answer? And the answer is they're both the right answer. These questions will give you two solutions. There's one exception, well, two exceptions to that as far as special cases go, but typically you're going to get two solutions. You can always plug them back in to make sure they work. All right, so here's the idea. I give you a problem. You have to know to set up two problems, right? And then just solve. So the first problem that we're going to set up, you just take the inside stuff, this x plus 3, and you say, well, it could be 5. Or the other one you got to set up is that the stuff inside, x plus 3, it could be negative 5. And then we solve. All right, so we're going to subtract 3 from both sides. And since I have to keep changing pens, I'm just going to go ahead and do that over here too. I really like these questions because you literally have the same algebraic steps. You just end up with different solutions at the end because you're setting them up with different solutions. I should think and not talk so much. There we go. So x equals 2 and x equals negative 8. Simple enough, right? So again, take whatever's inside the absolute value bars. So this stuff right here, this algebra, don't change it and set up your two problems. So 7t plus 3 could be a 4 or 7t plus 3 could be equal to negative 4. Either way it would work. So now we solve. I'm going to subtract 3. Ooh, my handwriting is not getting any better, guys. I kept complaining about it earlier in my recordings. I don't know. I'll be honest, I don't really have good handwriting any days, but it's extra bad. All right, one more step here. We're going to divide both sides by 7. This is a good case of show the division step so you don't have some upside down answers. All right, here we go. This guy right here gives you a t equals 1/7. There's one solution. And then here you get t equals negative 1. So that can't be bad, right? I know you're looking at those going, oh, it's got to get bad. Really, no. There's a couple of issues, though, that we run into when we assess this. Sometimes kids forget the rule of this splitting up into two problems. It can only happen when you have an absolute value that is isolated. You have to get that thing, that absolute value, totally by itself before you do any separating. So these two examples, you have to do that. The 2/3, don't distribute it into, yuck. Let's just get rid of it. All right, so we're going to multiply by 3/2, the reciprocal of 2/3. So now we've got still the absolute value of 1 plus 2x equals, that's a 3. Now is when you can separate, all right? So you take the stuff that's inside the absolute value bar and you separate this into two problems. You say, I should be using colors, huh? 1 plus 2x, it could be 3. Or 1 plus 2x, it could be negative 3. And now we solve. So subtract 1. Do that over here too. So we have 2x equals 2. But over here, you've got 2x equals negative 4. And then final step on both of them, you're going to divide by 2. Now, I don't know about you, but I noticed the next problem has stars on it. I'm getting a little nervous because I know stars don't mean good things in math notes. We got this. All right, x equals 1 and x equals negative 2. Ugh. Come on, handwriting. All right. So, first issue I see in number 4 is I'm not ready to separate the problem yet because the absolute value bar is not isolated. So you must isolate first. So first things first, let's subtract this 5 over. So now the problem says the absolute value of 2 minus 4x, it equals negative 2. And I'm going to write a big note to self. If this ever happens, stop. Now, I wish this was a live recording, and if we're watching this in class for some reason, whoever's in charge, I would like you to pause the video, and I want kids to think about, why did I just write stop? Well, I want you to write stop because you shouldn't do any more math at this point, because the solution should be, I don't want to say obvious, but obvious. The absolute value, so whatever is here, right, is always something positive because it's measuring distance from 0. So I don't know what x is right now. I'm not going through the effort of solving it. But when I plug it in, like all that mess, like it has to be a positive number. Can it equal negative 2? And the answer is no. An absolute value, a number that's always positive, cannot equal negative 2. So then you can write a couple of different things. You can say not possible. Or what most algebraic people write is they write no solution. Because if you're trying to solve and you can't solve it, that means there's no solution. Okay, now here's the troubling part. If you didn't catch that and you set up your two problems, I hope you would have caught it at that point, because you would have been like 2 minus 4x equals negative 2. That's weird. We've never had a question where it started negative. And then you would have set up 2 minus 4x equals positive 2. You would have gone through the math, you would have solved it, and unless you thought to check your answer by plugging it back in, you would have never caught your mistake. So this right here, write a big note to yourself, this is a special case. I don't think I'll try to trick you on a test for this, but that doesn't mean someone else might not try to trick you, like the SAT test perhaps. So watch out for special cases. I believe there is one more. Excellent. And that was the end. Okay. Gotta remember to stop. So this next problem, big note, guys. These last three have all been the same way, but there's one on your test like this. You need to isolate first. You can't do anything until you isolate. No setting up of two problems. So isolation, if there's more than one thing you have to move, you got to move it in that order. So we're going to add the 3 first. If you divided by 5 first, you would have had fractions. Ugh, no thank you. All right, so you still have 5 times the absolute value of 2 minus x equals 15. So now when I divide both sides by 5, finally we're isolated. So we have the absolute value of 2 minus x equals 3. I'm going to write a little note after this point right here. That's all been isolation, okay? So now we can think about setting up our two problems. So the stuff that's inside the absolute value bar is the 2 minus x. 2 minus x could equal 3, or 2 minus x could equal negative 3. And now we solve. So I'm going to subtract 2 from both sides, and I'm actually going to do that in both equations. It's kind of nice. Careful though, you still have a negative on the x, so negative x equals 1. And then right here you have a negative x equals negative 5. So one more step, we're dividing or multiplying both sides by negative 1, which reverses all of our signage. So we get our two solutions of x equals negative 1 and x equals positive 5. So I had mentioned earlier in the lesson that these will typically always give you 2 answers, like our traditional case ones here. The only exceptions to that would be if your solution equals 0 when you go to separate them. You can't do anything with a 0, right? So you're just going to get one solution. And then if you have a special case like we had on the previous example where it wasn't even possible because there's no solution, that would be a very special case. And do watch out for that on your homework. I'm sure I tried to trick you on your homework. All right. Good luck, everybody. It's time to practice.